Hey there, Dr. Jared Rathel here, and I welcome you to your Module 7 case study, which is entitled The Impact of Variation in Calf Survival on Elk Population Dynamics in West Central Montana. So this case study is based on research that I did as a master's graduate student at the University of Montana many moons ago, beginning in the spring of 2002 and finishing up in the fall of 2005. So this was a cooperative effort. We teamed up with the Montana Department of Fish, Wildlife, and Parks, and we received funding from several nonprofit entities, including the Rocky Mountain Elk Foundation, Safari Club International, and the Boone and Crockett Club. So our research teams were able to radio mark 121 neonatal calf elk, newborn calf elk, with VHF, very high frequency radio transmitters that have a mortality switch. That way we could determine cause-specific mortality rates of these elk calves in this elk herd that showed declining recruitment. I'm really proud of the work that we did here because this work really shed some light on what is truly driving interannual changes in population abundances of elk herds that are observed by wildlife managers in the western United States. So hopefully you'll find it enjoyable. So just like last time, there's a case study in a Word document that's in Canvas. I'd ask that you open that now if you haven't done so, and please follow along through this presentation and just go ahead and directly input your answers into the Word doc to be uploaded to Canvas. So some of these questions are somewhat subjective. There are no right or wrong answers. A lot of it, or there's a handful of questions about experimental design as well as interpretation. So don't sweat it if what you choose to measure or how you interpret these data are different from the way we did, okay? So this is based on your participation and your engagement, as well as providing me some thoughtful answers. Okay, so we were located, our study site was in Hunting District 292, which was about 40 miles east of Missoula, Montana. So this is west central Montana here. This is Missoula. This is where the University of Montana is. You guys may be familiar with Bozeman, which is down here, just north of Yellowstone National Park, which is here. But we were in the Blackfoot Valley, so the Blackfoot River runs right through here, as well as the Garnet Mountains here. So I would point out that this represents the largest contiguous tract of wilderness in the lower 48. So this is Glacier National Park, and it's going to tie into the Bob Marshall Wilderness, which runs all the way down past Seeley Lake to Ovando at the edge of our study site. So this represents a corridor for those recolonizing wolves, which I'll discuss here in just a second. However, if we zoom in for a closer inspection, this is the northeastern corner of our study site. Even though we're on the edge of this very vast contiguous wilderness area, our study site still represents a heavily modified landscape. So this is still dominated by human activity. So this is the winter range here, the low country along the Blackfoot River, and you can see that it's almost entirely been converted to agriculture. So this green, these bright green areas, these are alfalfa pivots, they're irrigated plots. And then if we move up to summer range, upcountry into the Ponderosa Pines, again, you see the fingerprints of humans all over this, right? So the landscape is pockmarked with clear cuts like you see here, as well as lots of logging roads. Okay, before we get too deep into this, some basic elk terminology. So hunters and wildlife managers are going to refer to female elk as cows. So this is a cow elk, and then this is a calf elk. So it's considered a calf from the moment it hits the ground, like you see here, all the way up until its first birthday, beyond which we then call it a yearling, as we discussed when we discussed age classes in our last lecture. You can also further subdivide that first year of the calf's life up into the neonatal period, which is typically about 90 days, those first 3 months getting us through the summer period, and then the juvenile period, which is typically the fall and the winter. Similarly, we refer to immature males as spike bulls. Remember Cervus elaphus or Cervus canadensis, the elk, the wapiti, the red deer if you're in Europe. They have antlers, so they grow antlers every year. They don't have horns, which we'll talk about when we talk about this order here later this module. So their first set of antlers that they grow typically doesn't have any branches. It's just a single spike. So this spike bull is likely 1.5 years old, where this is clearly a mature bull, often referred to as a branch antlered bull. So they're going to get their first branch antlers usually at 2.5, but this is a prime aged bull, so this is referred to as a 6x6, 1, 2, 3, 4, 5, 6 tines on the antlers, 6 on each side, a 6x6. So this is a prime aged male, so it's minimum 6, 7 years old. It may be as old as 10. Every spring across the western United States, wildlife managers for various fish and game agencies are going to get up into little fixed-wing aircraft, and they're going to systematically survey your ungulate herds. So these are typically called spring green-up surveys, and they're a measure of recruitment of elk calves that were born the following year that are about to be recruited into the population as yearlings. So I did these spring green-up surveys between 2002 and 2005 on this hunting district for Montana Fish, Wildlife, and Parks. This is a photograph that I took. This photo, like all photos in this presentation, were shot using film. This is before digital cameras were widely available, so that's why it's a little grainy. It's been scanned in. But you get up in these tiny little fixed-wing aircraft. So this is a Super Cub. It's just a little two-seater. My pilot was the famous Roger Stradley. So Roger's flying the plane and I'm in the back. And the goal is to count and classify the elk herd. What do I mean by that? This is a cow, 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 calf, calf, calf. And so what you're going to do is you're going to generate this metric called a calf-cow ratio. So managers want to know how many calves are produced per 100 cows because it's a measure of recruitment, the number of young that are going to be recruited into the breeding age population, the calf-cow ratio. You can also generate bull-cow ratios, and I'll be discussing both of those in this presentation. But let's start with calf-cow ratios. So the major management concern, the reason why we were funded to do this work was because of declining spring green-up calf-cow ratios, which again are an index of calf-elk recruitment. And we know recruitment is a measure of the young that are about to enter the breeding age population. So I've got our study site circled in yellow, but you can look at trends across all of western Montana. So this is average calf per 100 cow ratios between 1970 and 1991, so a 21-year period. And you can see in many places over 50 calves were counted per 100 cows. On our study site, it's between 30 and 50 calves produced per 100 cows. Okay? However, when I start this work in 2002, calf-cow ratios on our study site have declined to less than 20 calves produced per 100 cows. So the first question I have for you on your case study is, what was the management concern? What were managers worried about with respect to Rocky Mountain elk populations in the Blackfoot Valley in west central Montana during the early 2000s? In other words, what was the predominant question in our research effort? Hopefully you picked that up. So to begin with, I needed to put these declines in calf elk recruitment into context. What else was going on in the system? What else were we observing at this time? Well, one of the things that jumped out at me right off the bat was the increase in mountain lion harvest in Region 2, which is west central Montana, which peaked at 267 cats in 1998 and then falls off precipitously. So my initial thought was that lions may have been over-harvested and mountain lion populations were suppressed, reflected in these lower harvest rates. But I learned a valuable lesson in talking to the management biologist. It was actually the houndsmen, the lion hunters in 1998 that petitioned Montana Fish, Wildlife, and Parks to restrict lion harvest because they were worried about overharvest. So during this period, Montana Fish, Wildlife, and Parks was restricting mountain lion harvest. They were reducing the number of permits issued. So less lions were being harvested. So what that meant was there were more mountain lions in the system in the early 2000s than there had been historically. Of course, we know mountain lions are a primary predator on calf elk. So I talked to you about the work that I collaborated with out of South Dakota when we talked about the fundamental versus the realized niche. And we established, at least in the Black Hills, that mountain lions can exhibit top-down regulation, suppressing elk calf herds just by their sheer predation rate on the calves. So this is a significant predator of elk. We also know from bear hair snare studies that Montana Fish, Wildlife, and Parks had done, and other folks had been up to, the USGS, that both black and grizzly bear populations were also increasing at this time in west central Montana. And bears were also thought to be a predator on calf elk, although we didn't know the extent to which bears would play in this system. And then perhaps of greatest concern, at least to sportsmen's groups, was the recolonizing gray wolves. So wolves were moving into the area, into the Blackfoot Valley in the early 2000s. Important to note, these were not likely wolves that were descendant from the wolves that had been translocated into Yellowstone National Park in the mid-90s. These wolves probably recolonized on their own from Banff National Park down through Glacier and the Bob Marshall Wilderness. But regardless of how they got there, wolves were moving into the system. So within the Garnet Mountains and the Blackfoot Valley on our study site, we could confidently say that mountain lion, grizzly bear, black bear, and gray wolf populations of predators on elk were all increasing. So, was calf elk recruitment being regulated by top-down forces? Was it the predators that was limiting the number of calves that were being recruited in this elk herd? The second big observation that I made was based on looking at the flight data. So these are spring green-up flights from 1980 to 2003. Time is on the x-axis. So the calf and bull cow ratios are here on the y-axis on the left-hand side. So we'll start with this red line. This is the proportion of calves counted on spring green-up flights in Region 2, west central Montana, from 1980 to 2003, and you can see we've got 48 calves per 100 cows in 1980, and then that declines. We see this steady decline all the way to the 2000s, and I did several of these surveys, and we were at mid-20s calves per 100 cows, so essentially half of the calf recruitment that we'd had 2 decades before. But the other thing I want you to note here is this green line. So this green line is total number of elk observed on green-up flights. So this is an index of total abundance. So the pilots and the managers are flying the same areas year in and year out for consistency's sake. In 1980, 5,672 elk were counted. By 2003, 16,331 elk. So we see a tripling of elk abundance in Region 2 during this time period. And we know that elk are a slow tempo, K-selected species. So when that population abundance gets over a certain size, we have that inflection point, and population growth is going to decline. Okay, so the second observation that we make is that elk populations have dramatically increased. So maybe it wasn't the predators at all. Maybe it was bottom-up regulation. So maybe the elk herds had gotten so dense that vital rates were beginning to be impacted. Maybe less yearlings were getting pregnant. Maybe prime-aged adult cow elk had lower pregnancy rates. Maybe on elk winter range, you have high densities of elk and you don't have a lot of forage. Who's going to lose out? It's going to be those calves. They're the most likely to not make it through those lean months. And if they don't make it through, if calf survival drops during the winter, then so does calf recruitment. And then the third trend that I want to bring to your attention is the proportion of spike bulls harvested relative to every 100 branch antlered bulls harvested. And the data was available from the late 1960s only up to the 1980s, but the trend was clear. Hunters were harvesting a greater proportion of these young, immature bulls relative to prime-aged mature bulls. And that wasn't via preference. That wasn't because they were trying to go after spikes. That doesn't make for a very good trophy, right? So most hunters want to harvest that big, prime-aged, mature, branch-antlered bull. However, they end up harvesting spikes because this is a reflection of what is out there. So the concern was perhaps these herds had a very low proportion of prime age branch antler bulls. Well, how might this impact recruitment? Okay, so follow me. So these spike bulls, these immature bulls, they don't really know what to do during the rut. They don't have a lot of life experience. So remember, the cow elk are going to all go into estrus at the same time in the fall. It's called the rut. Okay? When they go into the rut, remember, these are polygynous species. So you have one prime-aged bull with this harem of cows, and he is going to breed all of those cows in a short amount of time. So in doing so, the gestation period is relatively fixed. So as we move into the spring, all of those cows that became pregnant at the same time, they're now all going to drop their calves at the same time. They're going to have a very synchronized calving period. And this is a strategy. The idea is to satiate the predators. So you remember the type 2 functional response of predators? So as the density of the prey goes up, the predation rate actually levels off. Why? Because the predators get full. They can't eat any more prey. So the idea here with this synchronized calving period is to flood the system with calves, and then the predators are only going to be able to kill so many of them, and the majority of those calves make it through that dangerous neonatal period. However, if there aren't enough prime-aged mature bulls in the system, if you only have these immature spikes, if they don't breed, the cow elk, when she first goes into estrus and she ovulates and she releases that egg, if that egg isn't fertilized, it takes 22 days before she'll release another egg. So what could happen is, if you don't have enough mature bulls, that rut can suddenly be strung out over a long period of time, which then means the subsequent calving period is strung out over a long period of time. And then the total net effect of predation may be considerably greater. All right, so I know I threw a lot at you, but given the three observations that I just described, increasing predator populations, increasing elk densities, and decreasing mature bulls, formulate three hypotheses. Remember, a hypothesis is just a possible explanation that might explain the observed declines that we were witnessing in calf elk recruitment as indexed by declining calf-cow ratios. So I'd like to take a moment and point out that when I started this project, the prevailing hypothesis among most wildlife managers and our research team was that it was most likely predators that were exerting top-down influence in regulating this elk herd. That was certainly what they were witnessing just across the state border over in northern Idaho. And as I've mentioned, my advisor, Dr. Dan Pletcher, and his students had already documented that wolves had recolonized the area. We knew that mountain lion harvests were suppressed because Montana Fish, Wildlife, and Parks had restricted lion harvest. And I should note, on my study site, mountain lion harvest had been completely shut down in an attempt to allow those cats to rebound, as well as multiple population estimates of expanding grizzly and black bears. So we know that these predators were increasing, but were they the culprits? So this is why we do science. This is why you got to get out and do the field work. So we sought to test not just increased predation, but a suite of hypotheses systematically. We used what's called the hypothetico-deductive method, which I'll cover here shortly. But essentially, we put forth several hypotheses in an attempt to explain declining recruitment, and then sought to design an experiment, our experimental design, to knock those hypotheses down, to disprove them. Okay, the first that we tested was obviously increased predation. Perhaps elk herds were being regulated from the top down, and predators were suppressing calf elk survival and recruitment, which I called the big bad wolf hypothesis, although it's maybe more than just wolves. The second hypothesis that we tested was perhaps this was an example of bottom-up regulation. We know that elk exhibit density-dependent logistic growth, so perhaps growth rates were slowing, and this elk herd was reaching its ecological carrying capacity, and these increased densities were manifesting as decreased pregnancy rates and or decreased survival in these calves, which was suppressing recruitment. We call this the too many elk hypothesis. And then the third hypothesis that we sought to explicitly test was maybe it was a lack of mature bulls because of the harvest regime of the previous decades. Maybe there weren't enough mature bulls in the system, and spike bulls were doing most of the breeding, which resulted in an asynchronous rut and then an asynchronous calving period in the spring, resulting in greater net predation rates. Okay, so 3 hypotheses that we sought to test in our experimental design. If you wanted to test those 3 hypotheses, what would you measure in the system? So think about how each of those hypotheses, the big bad wolf, the too many elk, and the lack of studs, might actually suppress calf-cow ratios. Mechanistically, how might they actually be doing it? Okay? And as such, what would you measure to either support or refute each of these? So pretend like you had an unlimited research budget, which that certainly wasn't the case with us, but money's no object. Make a list of what you would measure in this ecosystem in order to test these 3 hypotheses. And it's okay if you don't come up with the same list that we did. That's okay. I just want you to think through this like a scientist. All right, so what did we select to measure? So given our budgetary constraints, we measured all of these things in an attempt to test those 3 hypotheses. It was a pretty ambitious game plan. First and foremost, we needed to get at calf survival. We needed to know what proportion of these newborn calves were actually surviving. We need to estimate calf survival rate, as well as cause-specific mortality rates. The ones that were dying, were they dying from predation? Were they dying from malnutrition or disease? We also radio-marked cows to estimate their survival and to assess pregnancy rates. So we did this in 2 ways. One, by looking at the blood serum of radio-marked cows, and then also by sampling fecal progesterone levels. So we would, in late winter, spend hours watching cows and then collect fresh fecal samples to determine the level of progesterone metabolites to determine pregnancy rates in that way. We estimated abortion rates as best we could by tracking known cows known to be pregnant to determine if they carried their calf to term. We looked at calving synchrony. This was really important. Were those calves really all hitting the ground in a short period of time in the late spring in a very synchronized calving period, or was calving strung out? Fortunately, we looked at calf birth weights, and this turns out to be really important. Okay, how heavy were those calves when they were born, and did that fluctuate from year to year, and how does that compare to other systems? We also looked at predator densities. We were consistently and constantly doing predator surveys, as well as we did some flights for alternate prey, mainly for mule deer, to try and understand what mule deer populations were doing. So that's what we sought to measure. So I'm going to move into the methods now, and we're going to start with capturing these elk and processing them. But to really get a clear idea of how we did this, I want you to take the 7 minutes and watch the 3 videos that I've embedded in Canvas. They're not very long, but it's going to show you how our ground crews beat the sagebrush bushes looking for newborn calves that were stashed under the sagebrush, and how we captured elk on the ground, how we processed them, what things we measured on the calves, and then finally there's some really exciting footage that shows our use of the helicopter on our newborn calf capture. So this was a lot of fun. We pulled the doors off the helicopter so that I could jump out and process the calves, but the helicopter allows us to get way up into the mountains, into some of those areas that were hard to reach on foot. That way we could get a representative sample of elk calves from across the entire elk herd in the different calving areas.